This is number 9 from the January 2019 Regents. It says, which quadratic has imaginary roots? Okay, so my answer choice is 4. The reason it's 4, let's go with answer choice 1. If you look at the table for this function, I can see that there are 2 real roots here. Here's one, and here's one. The roots are found when y is equal to 0. So this, I have 2 real roots. I don't have any i's. I have a -2 and a -0.5. So those have, or this function has real roots. All right, here's my second function. It's a quadratic, and it has a real root right here. It's hitting the x-axis at 3. So this one has a real root as well. If it didn't, it would be a quadratic that was floating completely above the x-axis or completely below. That would be a function that didn't have any real roots because it would never hit the x-axis. All right. Number 2 is another way they give you the function. They give it to you with the equation. All right, so if I want the roots, I want to solve for x. So I'm going to do this a funny way, actually. I don't want to square that x plus 3, so I'm going to isolate that binomial. Okay. Now, to solve this, I can take the square root. I don't even have to square both sides to make my life a little bit easier. Now, the square root of 32 is irrational, but it's not imaginary. I don't have a negative underneath that radical. So this one has real roots. Even if I go further and move over the 3, it still has real roots. The real roots are -3 plus or minus radical 32. All right, last one, number 4, the right answer. Okay, I'm going to move over the 32. I'm going to divide by 2. And when I do 32 divided by 2, or I'm sorry, -32 divided by 2, you'll see I get -16. Now, when I take the square root, I'm taking the square root of a negative number, which means that I'm going to get a plus and a minus I answer. So this is the one with the imaginary solutions.